Hello, I'm John Furrier with theCUBE, host here at our New York Stock Exchange CUBE studio. Of course, we have our Palo Alto studio connecting Wall Street and Silicon Valley. This is part of our Mixture of Experts series. We interview the leaders who are experts in their field to unpack the core issues in technology. Got a great entrepreneur here, creator and database data systems, distributed computing. Joran Dirk Greef, creator, founder, and CEO of TigerBeetle, innovative company doing great things. In from South Africa, where a little trivia, EC2 team is there, a lot of smart people. Joran, great to see you again.
John, so great to be here with you.
People don't know this, but we were flatmates, as you said, or roommates, as we say in America, at our Maui trip with Bill Ty and the Acti global community, the kite surfing community. All the pros were there. You're good. I'm learning. Brian Bauman's very good. The NYSE Wired community is thriving and growing. Thanks for being part of it. Thanks for coming in.
No, thanks. So it's such a pleasure.
I got to know you in Maui, and we had a long chat about some of the things you're working on. TigerBeetle, very well funded. You got some great investors. You build some great technology in an area that everyone loves, databases.
Yes.
And you're doing some very innovative things. So first explain TigerBeetle, what you guys are doing, and then let's get into how data is changing the game for AI, agents, transactions.
Yeah, John, yeah. So OLTP, it's the OG of databases. 40 years ago, the field sort of got started. There's been a lot of analytics lately, but with TigerBeetle, we went back to the beginning to 5 years ago, design the world's fastest financial transactions database, TigerBeetle, 1,000 times faster than modern legacy systems. And so that's what we're doing with TigerBeetle. How can we power the world's transactions 1,000 times more efficiently? Because of where the world is going, the world needs that kind of...
Explain TigerBeetle, the name, where that came from.
Yeah, so a TigerBeetle is a real creature. It's the world's fastest insect. Actually, the world's fastest creature scaled for body length. Really the fastest thing on Earth. Beautiful, metallic chrome, green, blue colors. Can detect bat echolocation even. It's a fascinating creature. And so it also thrives in tough environments around the world. So we were looking for a name, for the fastest transactions database. But it's important, not to be fast and big. You want to be fast and small, efficient. And so this thing is so small, so efficient, so fast, also beautiful.
Yeah.
Thrives in tough environments, TigerBeetle.
We're in an era now where you got to think small to be big, as they say, because you're seeing a lot of, I won't say disaggregation, but the way these large-scale systems are being built in the AI. If you look at NVIDIA, large-scale systems, there's kind of been a re-architecture of how memory and all these data flows, so data movement, databases are now core. The database is like a new element. I think one of the things we chatted about in Maui, which I found fascinating, was, I was like, oh yeah, the holy trinity is storage, compute, networking. Like, well, don't forget databases.
Yeah.
And OLTP, online transaction processing, has been known for very, I won't say niche, but very important things, banking transactions, a lot of large scale, fast systems that power real time.
Yes.
Now that is going into everything that we know.
Yes.
Explain this concept, this fourth pillar of database, so compute, networking, storage, which we all know is key to AI systems.
Yes.
But the database isn't your yesterday database. It's got to be new.
So I think that we say there's 3 hot problems in computer science: naming things, off by 1 errors, and what was the other one? Caching. So I think databases are really the hardest thing. State is the hardest thing. Most software, most computer science is stateless. So we have tons of machines everywhere in the cloud, but those machines come and go. They're ephemeral, they're transient. But where does our information reside? Where does the record, our clay tablets of the New York Stock Exchange, all these trades today, where are the clay tablets stored? And these are digital databases today, no longer clay tablets, but they're just as durable. They have to be. But it's that state, the library of the world's information, the world's transactions. Where do we store that? Yeah. That's databases. And that problem is becoming harder and harder because the volumes are increasing and surging because the world's just moving faster and faster.
Yeah, and we were also talking about a term, you mentioned it earlier, modern legacy.
Modern legacy. I think you coined that term.
I know.
Close to midnight in Maui.
We were having a few beers. It was fun. Yeah. But I brought it up as kind of like a tongue-in-cheek term because modern legacy, it's not obvious, but there is a modern legacy landscape, and we riffed on this for a while. Let's talk about that because I think there's an era of, hey, I bought an Oracle database or I bought this database, I got Postgres, I have this over here. you have a diversity of databases in these environments. It's not one database to rule the world. But modern, a few years ago, might not be modern
today.
So explain what your view of modern legacy is.
Yeah, so this is something I've just been seeing, and databases are like cathedrals. If you've read Ken Follett, Pillars of the Earth, journey of a craft person, they want to build a magnificent cathedral. It costs millions of dollars to build a database. These things get built every few decades. So most databases people use today, even in the cloud, they're at least 15 years old. Even all the hyperscaler databases, they're around 10, 15 years old. The most popular database is Postgres, MySQL, SQLite. 30 years old, Oracle, 50 years old, king of the mountain. So everything is at least multiple decades old. However, what is modern legacy? Well, it feels like 10 years is still modern, but actually 10, 15 years ago, since then, the world in the last 10 years, transaction volumes have surged 100,000x. Sectors like cloud, energy, gaming. We have new kinds of businesses and trillion-dollar companies that just didn't exist a few years ago. And so the databases of 10, 15 years ago were not designed for 3 to 4 order of magnitude increase in scale. They were just not, they are not specified to this kind of scale. And so with TigerBeetle, we had this opportunity to say, well, where are the volumes? Where's the scale of the world going? Not even, let's ignore the autonomous transactions from AI. Let's just think of the people, people that are now ride sharing or streaming, or everything is, 1,000 times more transactional. So how do we design a transactions database, not 50 years old? Let's design it not for 1,000 transactions a second, but 500,000 transactions a second. It's just it's a new way of just thinking, and it's just something we have to do because technology has to advance.
Yeah, and the modern legacy is a great description. You mentioned Oracle, the king of the hill. If you look at, we've been covering Oracle for 16 years in theCUBE. Of course, we've been following them closely. They've gone from the database that rules the world to a database that never goes away because it's like the clay tablets, as you said. But look what they're doing now. They are now in the mainstream cloud game. I just saw a picture of the new CEO of Oracle with Sam Altman. They've moved from the database position into critical infrastructure.
Yes.
Infrastructure, not database.
Infrastructure, yes.
So database is now that
data centers.
Data centers, data centers, database.
Networks.
We have a series called AI Factories. NVIDIA's a big part of that. They're leading the way. You can't have an AI factory without a data factory.
Yes.
So talk about the role of this transaction, because the other thing that you're seeing is more volume, more kinds of microtransactions.
Yes.
And this is not new.
Not new.
I mean, there's been micro payments around for years, so there's always been kind of micro things.
Yes.
How does that apply to infrastructure? Where do you see that trend intersecting with TigerBeetle? Because if the volumes are going up, check, we see that. Two, what kinds of transactions fall into the new OLTP?
Yes.
Is it agents talking to agents? Is it little gestures?
Yes.
Explain the new OLTP landscape.
Yeah.
We know what the old looks like.
Yeah. So we use a media analogy. So let's imagine like the world of business is a television screen. The New York Stock Exchange is a television screen, and we've got black and white color, and we've got big pixels. So we can do old grainy movies, and that's business. 10 years ago. In the last 10 years, that picture has changed. And now we've gone to, retina display. The pixels are so small you can't see them with the human eye, and they're multicolor. So it's rich color, and that is what the business world wants. We want higher resolution into our business. We want to know what are our stock levels, not each hour or, at the end of the day. We want to know what it is at this nanosecond. We want real-time resolution in nanosecond time. Old infrastructure is really pretty much by the hour. And so you've got, it's the same TV dimensions, but the number of transactions are more pixels, and they're smaller. And that gives you this real-time resolution into your business. So let me give us some examples. How does this apply in real life? So if you booked an Uber trip today, maybe you booked 5. I didn't book a rental car coming here. A rental car, you go somewhere, you book it once for 3 weeks. Now I do 5 trips a day. So much smaller in value, many more of them. Real time is better for me as the consumer, supply and demand meeting more frequently. And so look at content, it's the same. We used to buy an album, then you buy a song, 99 cents. I can't even remember that world. You know,
iPod.
iPod. Who has an iPod anymore, you know? And 99 cent songs no longer. And now you just stream by the second, and who knows how the billing is done.
I love the picture. I love the picture example, because I interviewed the head of technology at the NHL here at the NYSE, and he was showing me some 8K footage. Yeah. 8K. Unbelievable. It's like it's like you're at the game, and they're going to do that. But the pixels is a good representation, because at any given time they can be activated and turned on. Pictures are always changing. Yeah. That's the data in your business. Yeah. So you got to have the pixels first. Yeah. Small little pieces, can't see it. Yeah. That's little transactions happening for a big picture.
Yeah. And you need a lot of database power to power that display.
What's the secret sauce? Take us through. I mean, I love the market. I think you're in a good spot. Talk about the secret sauce.
What makes TigerBeetle fonts?
Yeah, the yield the IP, or talk about the algorithms. What's the secret sauce that makes it all work?
Yeah, so I think the key is that, 40 years ago, even 50 years ago with SQL, that SQL is a fantastic query language for getting data out of a database. It's great for reading data, and it's a general purpose database interface. So SQL, general purpose, great for getting data out. OLTP is very different, actually. The problem is, how do you get your business transactions in? How do you do business? Yeah. The analytics comes later. The SQL comes later. So the big problem is not how do we do queries in the data lake. It's like, we've got this big empty dam. How do we just get the water in it? Yeah. And that is transaction processing TigerBeetle. So we realized the world doesn't need another string database. We need a database that's good with numbers, like a database that can count and do it very fast, 500,000 a second. So the secret sauce of TigerBeetle is pretty much just anatomy. Humans, we're pretty good at swimming. Dolphins are specialized. So they make it look effortless. So you could take a general purpose database, like a SQL database, any one of those. You could make it 10% faster like a human. We're going to train harder. But a dolphin is going to come along, and you just cannot compete with a dolphin.
It's elegant, fast.
It's a different category. One is general purpose, walks on land, swims on water. The other one is I specialize for transaction processing.
That's what you got. That's TigerBeetle. That's
so the whole, you cut the database open, the anatomy is different.
All right, talk about the small aspect. You mentioned the TigerBeetle name, small, the fastest by mass size. Talk about this phenomenon around how you can break things into small pieces, or database pieces, or pixels, if you guys use the analogy. Yeah. Why is that important? Why is that trend relevant?
Yeah.
So small databases in the aggregate better.
It's relevant because let's take an example from energy. So, the world has moved from coal. We no longer price energy once a month, kilowatt hour. We don't price that once a month. We now want to price that every 30 minutes. And the reason is because the sun is, the cloud coverage is coming in, or it's raining, or it's sunrise, sunset. So the price of clean energy now changes. And if you were to price this once a month, it's very inefficient. So you need to price energy in real time if you want to take advantage of clean energy. Now suddenly, your smart meter at home can be switching energy back and forth into the grid. And the faster you can transact, the more
more real time.
More real time.
What's the alternatives today? Because you mentioned it costs millions of dollars to build a database. Yes. Build it, they will come was the old model. As they say in the movie Field of Dreams. What is the alternative? I want to say, hey, I want to price energy in real time. Yeah. Without TigerBeetle, what do I do? What's my design room look like? What's the engineers around the table talking about? What's the scope? Scope that, and then talk about how TigerBeetle compares.
Yeah, so this is something that took me a while to understand, not only why TigerBeetle is specialized and fast for transaction processing, but why a general purpose database actually has a theoretical physical limit in terms of Amdahl's law. So if you were to take a general purpose database, even $1 million horizontally scaled cluster, you can take one of these. There's the promise that you can just buy more machines and scale infinity. But actually, in terms of Amdahl's law, you can't for transaction processing, contention. SQL rollouts across the network just don't scale. Even if you throw $1 million of hardware at it, it just doesn't scale. And so this was something I realized, that a general purpose database actually cannot handle today's load. And I came across this working on a central bank switch by the Gates Foundation, using a general purpose database, couldn't make it go faster. So what do we do? What you tend to see is huge investment outside the database in the application, companies are now spending millions on reconciliation. They run 200 machines of Postgres. They could be running 6 of TigerBeetle. So there's just a ton of cost and complexity outside the database. Building a database,
more complexity to make it go faster.
And it still doesn't go faster. So what they end up doing is the product experience starts to suffer. So all companies take on risk. So for example, a lot of fintech, they're offering real-time fintech products. Under the hood, they're still running on old-fashioned, daily batch rails. And they're taking that hit.
Yeah.
But if you have a real-time transaction system, settlement risk goes away, FX risk goes away. Your business is now, your exposure is far less. So there's multiple ways. Either your users are going to see it or your business is going to feel it in terms of risk. And yeah.
Joran, talk about the business, okay? How old are you guys? When was it formed? Employees, funding?
Yeah,
status of customers, momentum. Give us a quick overview.
Great. So we're only a 3-year-old company. We already work with some of the
3-year-old.
3-year-old. Yeah. So we celebrated 3 years this month. It's our birthday month, September. Thank you.
All right.
And so 3 years old. We already have some of the largest wealth management companies, brokerages around the world, Europe, South America, North America, Africa, all over Asia.
You're based in South Africa.
We're actually based in the US. So
okay.
US company, half our team in the US, half in Europe.
West Coast, East Coast?
Remote, a bit of both.
Okay.
Keep it fresh.
For remote.
East side, west side. Yeah. We're global remote.
Yeah.
And it's a great.
And you got some great backers too. Who are the financiers again?
So Spark Capital led our Series A. Amplify Partners and Coil led our Series Seed. $30 million in funding. Small team of 16. Multiple former CTOs, some of the best engineers that we can find, some of the nicest people.
Yeah. Amplify and Spark, very well known for investing in technical entrepreneurs.
Deeply technical investors.
Yeah, and that's the thesis that they have, which is a good one. I got to say, one of the things that's impressive about this is that even if you're only 3 years old, you got the right tailwind with the trend. The trend is your friend.
Yes.
One.
Yes.
People are struggling with the database. Use cases, because this comes down to, okay, where's the rubber meeting the road? What you mentioned, some of the big deployments. What's the environment where you're thriving in right now? Where's your landing zone right now for customers, and what are the use cases?
Yes, so some of our customers, they're billion-dollar unicorns. They're about to IPO. They want mission critical transaction processing. TigerBeetle, because of the speed, it has to be far safer than any existing general purpose database. We have so much more safety techniques, NASA, coding style. So we have customers that want that because they're about to IPO. They want nothing to go wrong. Stay out of the headlines. Others are just dealing with massive scale. So we had one customer come to us. They said, look, TigerBeetle, we've got a 100 million transaction workload.
Yeah.
We have to migrate this. We only have 45 days to do it because we want to take advantage of new market opening up to us. We have to launch by 1st of January. Our team was working around the clock to help them make it happen. And they went from 26 transactions a second with the general purpose limit with a SQL database, 26 a second, they saturated their central bank limit. They said to us, you don't know what a big day this is for us, how much business we could move because we can go faster. So going
They were happy. They're buying you a beer for sure.
Yeah.
I noticed you guys had a dinner event here in New York City. Dave Vellante and I attended. You're attracting a lot of talent to this mission.
Yes.
Also, other fellow entrepreneurs, ecosystem partners. What is the strategy for hiring? Who are you looking for? I'm sure people would want to probably join this. What kind of problems you're solving?
Yeah.
So what's the makeup of the person you're trying to hire?
Yeah.
And talk about your partnership strategy. Is there an ecosystem play here, or take us through how you're thinking about expanding and your thoughts on that?
Yeah, so our vision is we want to lead, the world's transactions, power the world's transactions for the next 30 years. We've had a great innings of 30 years the past, with general purpose databases. What does the next 30 years look like, the future? How do we design for that? So engineers are attracted by this long-term view of let's do quality.
Scale and speed.
Scale and speed, and the most extreme engineering we could do, Tiger style.
Yeah.
And really Tiger style is extreme, NASA coding. There's no waste in the database, so efficient, streamlined. So engineers, I think the thing that we look for is within 10 seconds, they come up to you and their eyes light up.
Yeah, they know the problem you solve.
Yeah, and my eyes light up, and I think this person is just would be so nice to be around, and they're highly talented. And we the co-founder of Rust works with TigerBeetle, the creator of Rust Analyzer.
Successful companies have that shiny new toy factor, and that can be a pejorative. It could be negative in the hype cycle. But when you actually have a better product, it's like, oh my God, I need that. And I noticed that the people that you're attracting in the conversation, first, I was enamored by it as well, are people that know the infrastructure game.
Yes.
That's why I'm kind of honing in on this fourth pillar of database, not as a software piece, although it's great.
It's software and hardware.
It's software and hardware together as infrastructure. So the people that you're attracting are people who worked at Palantir, Facebook, large-scale systems. These are nerds.
Yes.
These are large-scale
we love
nerds who are loving, because that's the problem, because they lived it.
Yeah, we think orders of magnitude. So we think, we could do something that's 2x, but we wouldn't do that. We'd do 10x, 100x, 1000x.
Yeah.
And we literally just design for orders of magnitude. It's just standard engineering.
What's the sales strategy? Do you have a sales force? Is it all kind of...
we do. Yeah. We do. So our sales strategy,
we just show the product and then just say their eyes pop out of their head.
Yeah, we say that engineering is marketing. So we've put so much into TigerBeetle, incredible. It's just our joy, that we pour out our craft. Then we tell the story of that, and that goes out. 200,000, 300,000 people watch our talks. And so there's hardly an engineer anywhere that doesn't know of TigerBeetle. And then they reach out when the timing is right for them. They knock on the door and we say, let us help you. And we turn them around.
You showed me a few demos. I'm not sure that it made it mainstream, but you have a crafty strategy of luring in the alpha nerds with kind of like a game to show them the value proposition.
Yes. Yeah.
What's the idea behind that? And what is that? What's the purpose of that? To say, hey, here's an example of what it would look like if you ran this way. So
databases, I see it as like this invisible world. It's like the movie Inception, where architects in an invisible world create these amazing things in machines and gears that turn and buildings that go upside down, but no one can see it, and our children can't see it. So
it's the invisible technology that makes things happen that no one's like.
And we're so excited about, but no one can see. I think
like mechanics under the hood.
And I think the best things in life are invisible. Stories, music.
Yeah.
And so that's why I love technology, because it's invisible. And then there's this feeling: how can we show this to people? How can we put a game engine on and they can actually see it? And run a cluster of tigerbeetles and hit them with a hammer and see them recover? Or how can we build a 3D racetrack and race databases on and see that 1000x?
Yeah. With real numbers, by the way, not like fake. So the smashing of the TigerBeetle,
it's running real code,
is simulating an outage.
Yes,
which is common. So you basically took database problems and turned it into a kind of a visual game.
And then we plug autonomy into that. So we take instead of AI, we do autonomous testing. We run 1,000 machines and they simulate autonomously all these kinds of events. So we do 2,000 years of testing.
I wanted to bring that up because one, it's clever. I liked it, but also it points to what I see in your world that'll be a great kind of future headroom, probably faster than when we all think. Is when agents come in.
Yes,
you're going to see them talking to each other with data. Those are transactions.
Absolutely,
and they're going to be in the zillion. There's going to be millions and millions of transactions no one sees.
Yeah.
And state is huge.
Yeah.
Because state is where the clay tablets are doing their thing.
To record those transactions.
Not ephemeral. You want to have delegation. You want to have some of these computer science concepts working, which is hard.
It's hard.
Explain that why the agents and what's going to be the future transactions that you think will be a big part of your growth.
Yes, and I think, if TigerBeetle is 1,000 times faster than 30-year-old technology, that isn't hard because the world has advanced in 30 years. There's just so much advance in hardware, software research. You can make a database that much faster. You should, Yeah,
you did.
I hope, we did.
But where does it go? The volumes aren't stopping.
And I think that's the thing. TigerBeetle's already behind, So when you think of like autonomous transactions, these things are now so fast and so fine-grained. Because and on top of that, you can't use very general purpose primitives like SQL anymore because of hallucination. So you need far higher quality primitives to give the LLMs. You need to give them debit credit so that you can guarantee correctness. Because now you have an audit trail. Did one LLM mess up? We've got the audit trail. Okay, we can do a correcting entry, but we've got the whole. So this is where debit credit, which TigerBeetle brings out of the box, is so important.
Yeah.
Better primitives for machines to reason with and build with.
Yeah, and I think your movie example is good too, because what you have on business is you want to light up the data at any given time. The scenes change.
Yes.
It's real time.
Yes.
It's different.
It's
generative,
but we can see it.
yeah, it's like nothing's on the TV.
Yeah.
All right, so where do you guys go from here? You're gonna head back to South Africa. You got a distributed team all over the world.
Yes, yeah. 6 of the team are in town. I'm popping back to Cape Town, just hop across the pond. I love New York City,
Yeah.
And we're taking a few professors from around the world: Copenhagen, Germany, Netherlands. Some of the top professors in databases. They're coming out. They're coming out to Cape Town in 2 weeks' time. We're taking them up Table Mountain. Do a little bit of a workshop up top there. I love databases so much. I went to Table Mountain. So.
I mean, when I got my degree in the 80s, one of my CS degrees was databases and operating system, but the database one was, at that time, wasn't very popular. To be a database person. Now it's the hottest field.
It is. It brings
it is a core pillar.
all the techniques of computer science, into this little thing that we build.
Well, congratulations, and thanks for coming on our mixture of experts as part of theCUBE and the NYSE Wired program and community. Thanks for participating, and congratulations.
Such a huge pleasure, John. Thank you for everything you do.
Thank you. All right.
Cheers.
We get the entrepreneurs, the creators, the technology that will make things faster, simpler, and if they do their job, they'll be invisible, but they're making things work. The transactions are happening, the state of the data. This is the key secret sauce to make generative AI and the new AI-enabled applications, AI-native applications successful. You got to have the horsepower. We're seeing all the spending on data centers. All that will be powering data centers with databases as infrastructure. Of course, theCUBE's got its own data we're streaming to you. We're doing our part. I'm John Furrier with theCUBE. Thanks for watching.